Our goal is to check convergence or divergence of the following series. The summation of 1 divided by 2 to the n minus 1. So for this one, you can apply comparison test, or you can use the limit comparison test method. For the comparison test itself, comparison method or comparison test, you have two cases. If an is less than equals to bn, you get two cases. Case 1, if the larger series is convergent, then you can conclude that the smaller series is convergent. The second case is if the smaller series is divergent, if the summation of an is divergent, you can conclude that the larger series is divergent as well. Another method that we're going to introduce is comparison using limit. So limit comparison test. In this method, you just take the limit of an and bn. As simple as that. Limit of an divided by bn as n goes to infinity. If the limit is equal to a finite positive number, if this is equal to something like c, this c is positive and finite, then the behavior of these two series are going to be the same. Then either both series are convergent or both of them are divergent. Then both series are convergent or both series are divergent. So let's take a look at this. Have I seen a similar series before? I remind myself. I try my best to remember. I try to remember a series that is similar to this series, and I already know its behavior. Well, if I take a look at this series, if I ignore -1 on the denominator and write it as 1 over 2 to the n, this is basically a geometric series of 1 divided by 2 to power n. All right? This is a geometric series. Since the ratio is equal to a half, an absolute value of ratio, which is absolute value of a half, is less than 1, we have a convergent series. So I found a series that is similar to this series. I either use the comparison test or I use the limit comparison test. Either is fine. Your goal, your job, your very first step is to remember a series that is similar to this one, and you already know the behavior. This is a geometric series. I know about it. I'm sure about its behavior. And R is equal to a half. The ratio is a half. The absolute value of ratio is less than 1. And indeed, it's a convergent series. So if you apply, let us apply limit comparison test. Okay, I'm going to take the limit of the division between these two series. It doesn't matter which one is on the numerator, which one is on the denominator. In this example, you have the limit of 1 divided by 2 to the n minus 1 divided by the second one, which is a geometric series, 2 to the n. As n goes to infinity, this guy can be written as the limit of 2 to the n divided by 2 to the n minus 1. You already know the limit. It is equal to 1, which is positive and finite number. So both series are convergent or both series are divergent. But since the geometric series is convergent, the other series must be convergent. So this is your conclusion. Using the limit comparison test, since the limit is 1 and the series of 1 divided by 2 to the n starts from 1 to infinity, is a convergent geometric series. So the series of 1 divided by 2 to the n minus 1 and starts from 1 to infinity must be convergent as well. So let us recap a quick summary for you. We are checking the convergence and divergence of this series. You can use comparison test, which says if an is less than equals to bn, if larger series is convergent, you can conclude that the smaller series is convergent. And the second case, if larger series is divergent, you can conclude that the smaller series is divergent. You can conclude that the larger series is divergent as well. This is second case. Or you can use limit comparison test. In the limit comparison test, you find a series that is similar in behavior and you already know how it behaves. Then you take the limit. If the limit is equal to a positive finite number, it means that both series are convergent or both series are divergent. By looking at this series, I remind myself of a geometric series that I have seen before. I know the behavior of the geometric series. This geometric series has a ratio a half, and the ratio is less than 1, so we have a convergent series. Now I'm going to apply the limit comparison test. Take the limit of 1 divided by 2 to the n minus 1 over 1 divided by 2 to the n as n goes to infinity. But this limit is equal to 1, which is a positive finite number. What's the meaning of that? It means that these two series are both convergent or both divergent, but since this geometric series is a convergent series, it means that the other series must be convergent as well.